what I'm going to show in the slide is a little bit of an introduction of what our goal, what is our mission in Cisco for automation. Basically, a few slides that you've probably already seen, but just to level set the audience, I will go through them very quickly. You can stop me whenever you want for any question, because the first few slides I will go a little bit faster. Our mission is around the three major pillars, that is visibility, insight, and action. So when we're talking about automation, the automation is basically bringing all together all of these three pillars in a closed loop automation. So starting from visibility normally is where we collect information from the network and visualize all the devices, all the services that are configured inside devices in a topology network, so to see how the traffic is flowing and overlaid with additional information. The insights are the way of collecting management information, performance, latency data, packet in, packet out, errored packet, power levels, any insight that the network can provide, and we can overlay to the network itself to actually take action. So the closed loop is basically leveraging on the inventory of the devices, the configuration of the devices, and the actual data that are coming from the devices, usually through telemetry, but it can come with even SNMP or CLI commands, or all the other way. All the methods are valid for us to collect data. Of course, we are trying to leverage as much as we can on standard models and standard interface like OpenConfig, GNMI, and telemetry. But all of that is basically taking all this data and close the loop with action, so setting or modifying the network so that it can adhere to the intent that the operator had in mind when he has designed the network and would like to have when operating the network. So this is basically the vision that we have, very high level. And if you go a little bit in details, this is what we mean with all the different elements. The visualization, again, as I was mentioning before, collecting all the information from the network and visualized in a actionable or in an interesting way in the topology, so that you can have already insight on how the network is built. But then also we have all the other elements like the assurance that is dealing with collecting the key performance indication, data through telemetry, so that we can actually make sure that the intent or how we wanted the network to work is actually working as we were expecting, and so on and so forth. Again, so this is the flow or the workflow that we have in mind when we design our application. We have a planning in mind where we start designing the network. The optimization phase is basically the core of the closed loop automation. Basically, the fact that we are collecting insights from the network and the fact that we are able to close the loop with modifying how the network behaves is basically to achieve optimization in the network. So how we can optimize the resources that our customers and your customers is actually implementing in the network. We also have service provisioning. The additional element that we have on top is the workflow. So we have a new offering that is a Crosswalk Workflow Manager. It's an application that it's helping us to make all of the steps inside this loop, or even even not in closed loop, but in any workflow that we are building inside the network, to automate it and make sure that we can customize it. So it's something that I will discuss a little bit later on in the flow of the presentation. So that being said, this is our architecture. So we are moving away from the traditional model of EMS, NMS, and application like planning that are not integrated each other. So we are moving towards a model following also the industry standards and following also the industry trend. We are going towards what the industry call the controllers. So the controllers in reality is a new way of managing the network. So we are controlling the network via software. And what we mean controlling the network is, again, based on the three pillars that I presented at the beginning. So collecting the data, visualize this data, collect more insights, and then automate some action that makes sure your network is working as you are designed and how you have in mind to accomplish the requirements that we call intent in automation. The intent that was designed at the beginning when you had the network in mind and how you wanted to operate the network itself. So this is basically the way that controller works. So the main difference, the addition, or I would say why we're going towards controller and moving away from a traditional system, is because controllers are based on smaller modules, so they're not a monolithic piece of software. They are usually based on microservices, as our architecture are, and I will describe a little bit later. So all of these elements are small individual elements that do some specific function, and they are tied together using enterprise bus. So we are basically leveraging on Kubernetes, if you have some insight on what we are using. So we are basically not having a discrete application that works independently, but we have modular functions that we can build together and configure together in an enterprise bus and working together on the same network model. So that's the main difference between the previous model and the new model. Of course, the controller are also having in mind the automation, so they are more programmable. We work mainly with the API, working between the different modules and also working northbound and southbound. So the intervention of the operator on the graphical user interface that in EMS, NMS was kind of the normal way of operation, in the controller way is mainly a way of controlling how the application, how the workflow, how the automation is working, and just supervising it, not just being the main actor to use the management application. So the user in this case using the UI is more a supervisor, and the application itself, all the modules together in this closed loop automation are working based on a workflow that is designed, configured, and customized. So that being said, our architecture is based on 2 layers. It's a layered architecture. So we have domain controllers. So for instance, we have an IP domain controller that in Cisco we call Cisco network controller or crosswalk network controller. We have an optical domain controller that is the Cisco optical network controller. And on top, to have the end-to-end visualization, we have the hierarchical controller that is basically an upper layer that is bringing everything together, normalize the API northbound, but is also providing the single pane of glass, a single UI for the user to actually verify and supervise that everything is working fine. As you can see on the right, I'm still, let me use this pointer. If you see, so on the right here, I still show some discrete component like NSO, that is our provisioning tool. You probably are very familiar with the application. It's very popular. I will describe more in details a little bit later on. But NSO is our component for provisioning. So it's our engine for provisioning. Can be used as a discrete component. For instance, if your customer just want to provision the network, a multi-vendor network, very, very popular NSO is because it's having a lot of adapters for different vendors and different technology. But this component is also used inside our architecture, inside our controller for making the same function. Later on, I have a slide that is showing why we are still keeping the discrete component and this integrated architecture, but I think you can pretty much imagine it. So the integration of all of them make a lot of benefit to the end-to-end workflow that a customer may have in his network. So if we purchase all these components as a pre-integrated architecture that we test inside Cisco and we deliver to the customer, it's much easier to deploy this type of solution. You have less customization. It's still possible to customize, but it come already with some predefined use case that we have pre-tested in our solution. But of course, if you are an existing customer, or if you want to deploy only the discrete component like NSO, EPNM, One Automation Engine, or even the cross workflow engine, that is the new product that we are about to deliver the first release, you can still do that. So this is the flexibility of our architecture. So there is no need of building and integrating and deploy a solution that is this one and that's it. So you can pick and choose the different components and even run them as individual element. So that being said, this is what I was mentioning before. So we started from a number of products. Some of them either are coming from acquisition, like I would say most of them are coming from acquisition. HCO is the Sedona acquisition. It's a product that we acquired for bringing together different domain. NSO, it's an acquisition that we took. It's probably many years now. One Automation Engine is also coming from an acquisition. So we come from a number of products that we acquired in the market. So we invested a lot on these products, and then what we are making out of them, we are making them an integrated suite of application running on microservices. So that's the beauty of the fact that we can use one of them or even all of them together, connected each other by an enterprise bus. And we still have the flexibility that you can see on the right to use them as a single packaged ecosystem that we pre-test with some use cases already in mind, and this is the upper portion. But we can still sell them as a discrete component for customers that wants to customize and adapt their environment to what they have in mind on their architecture. So we don't want to mandate our best architecture for everyone. So everyone has its own architecture in mind. So we can use this building block, like in a Lego, to create the architecture that you feel is the best. So having this in mind, I would go through the different use cases. Actually, I have a few examples. I selected this example from the use cases that we can implement with our architecture because was presented as architecture or new elements in the previous presentation. So I'll start with the routed optical networking. So in the first session yesterday from Ben, if you remember, Ben started from the fact that the cost of silicon is going down over time, and it's basically increased its capacity with the Murphy law basically doubling every year or even more, while the cost of optics is basically still remain the same. So if you look about an holistic network with packet and optical, so now the optical is becoming the majority of the cost of your network, while the silicon, if you look about the capacity or the cost per bit, is basically decreasing dramatically. And this is the reason why we have in mind, or we started a few years ago to design this network that we call routed optical networking, that is basically taking a lot of optical elements that are building a traditional transport network directly into the routers. So for instance, nowadays, potentially you don't need to deploy transponders. Your customer can simply buy pluggables, optical coherent optics pluggable, and plug directly on the routers, so that interface, that is a router interface, can be directly inserted into the DWDM system, removing a lot of equipment, like all the transponders, all the filters. Sometimes filters are needed, but basically all the electrical to optical conversion that you have in the transponder, the gray optics that you are using to connect the routers to the transponders, all the cabling. So, and the benefit of this is not just the reduction of the hardware that you're not using anymore, but the fact that less element you have in the network reduce drastically the mean time between failure, reduce the power consumption, and this is also another important factor given the uncertainty that we have in the energy market. So this is the basic why routed optical networking. We started with the routed optical networking architecture a few years ago, and it becomes very successful. And it's one of the transformation factors that our service provider customers are actually going through right now. So why I'm telling this? I'm telling this because there is no routed optical networking without automation, meaning that previously our customer were using the transponder as a clear demarcation point between IP and optical. Now everything is merging together. So you have a single network because actually the optical transport is terminating on the router that traditionally are the IP domain or the IP where the IP is basically switched. And so you need to have the software, you need to have automation in order to not only keep the same level of configuration and assurance that you had previously with a single domain. Now we can bridge to domain, but also since the fact that the protection mechanism is now moved to the IP, the resiliency is moved to the IP, then you need to have a simple application that is able to design the protection schema in the IP layer and also making sure that the protection is working as you're expecting. So again, visibility, and then is able and adapt the network to changes. And this is the action that we had before. And automation is basically do this. I have some example. I will double click on these use cases in the following of the presentation. So now I just want to bring you the use cases where we need automation to make the transition to the architecture effective. So routed optical networking is the first example. Second example is transport slicing. So again, in the beginning of this conference yesterday, Ben, one of the critical point, one of the most interesting point about our network is that we are now integrating different services on the same network. And one of the tools through which we can achieve that is slicing. Why slicing? Of course, because if you integrate different services, like could be consumer services, business services, 5G services, all of them, gaming, for instance, all of them are different characteristics. Gaming, for instance, latency is critical. For bank connectivity, sometimes latency is critical, sometimes the reliability is critical. Other type of application like the 5G for, for car automation, self-driving are critical on the latency, but not generating a huge amount of traffic. So you will see each of these services are different profile. And of course, in the network, you have to implement different transport to cope with these different characteristics. This is why we call all of them slices. So slices are basically something like layers, but layers are in different technology or in different type of pasta like lasagna. In this case, slice is as slices of the same element. So slices, in this case, we are talking about slice for forwarding plane. So we have different forwarding plane, and that's why we call slices, because they are homogeneous element or slices in the same technology. So since we have these slices, you need to have something, and this is the automation tools that are able to make sure you manage them. You create some kind of predefined slice configuration. We have templates for doing that. You need definitely to have something that is able to provision all of this configuration in the network, because now you don't have anymore a single configuration for your forwarding plane, but you have 2, 3, 4, 5, depending on the services that you are using. And so the automation tool, in this case, the Cisco network controller, the IP controller, is actually able to provision 4 or 5 different elements in the network as you were provisioning only one. So the complexity is reduced because you have the automation tool doing that. In addition to that, of course, there is optimization. So you have to optimize every single slice depending on, for instance, latency. So a new service that is based on latency optimization require different type of optimization that a service that is designed for being bandwidth optimized as different kind of optimization. So this is what our automation is helping to do. And this is why CNC or our IP domain controller is critical if you are building a network with slices. And slices now is becoming a mandatory requirement for for implementing a new network with different services. So that's the transport slicing. We also have any questions? So I'm going too fast or saying things that doesn't resonate to you. I think it's something that you have already seen and maybe a repetition, and just basically for me trying for you to give you some inputs on how automation can be used in this different technology. So another area that was mentioned yesterday as one of the key points for the network is sustainability. So sustainability, of course, deals with the fact that not only our devices are more circular, we can recycle them, but also the fact that we can optimize the carbon footprint of our network by optimizing how we are using them. But in order to optimize a network, you definitely need to collect data point. Data point that we are collecting are based on key performance indication that we are taking from the network itself. In this case, our performance data related to the power consumption, to the impact that each single devices that we are using in the network are producing. So all of that elements are the key elements that we are using for the planning. So by planning how we plan the routes inside the network, how we plan the services, but also in real time, how these elements change in the network while we are using the network. So collect again power levels, power consumption from the network, and then re-optimize the network as we are using it. So the CNC, the IP domain controller, is able. We are working. We already have a first implementation, and we are working that to make sure that all of these elements will be used more and more in the optimization of the network. So this is again another use case on which our automation is a key element for making or achieving the goal that Cisco is having in the network. Yeah, I say that this is the last use case I want to mention is Metro Edge automation. Probably we haven't talked about yesterday or even today in the presentation, so I haven't seen it. But one of the major generator of carbon footprint, but also the devices that are more impacting in the network are definitely on the edge of the network itself, so where you terminate the services. And traditionally, these edge devices are very centralized in few locations. And this is the picture that I see on the left portion. So if you look about a network, you definitely have the user, you have the metro network that is used for doing the aggregation, and then you have the core. Of course, at the ingress of the core, you have the edge devices, and you exit from the peering edge. But this, as you can see, we make them big because these are actually physically the largest devices because they are terminating services, terminating all the protocols that we are using, terminating the different functions that the core network is having. So traditionally, these are the devices in which our customer and your customers are spending the majority of their investment in building them. And sometimes they become so big that it's difficult even to manage them and to. So we have some example in few networks that I remember we are managing. So for instance, in Germany we have the router in Frankfurt that is basically blowing up because of the capacity and how big they are, because these locations are becoming more and more important. So the fact that and just one point that I forgot to mention. So the reason why we build this network in this way is because traditionally the services or the access point, or for instance the access to the internet, the access to the data center, were also very few and localized in some locations. So usually in this co-location, it's in this site is basically the co-location where you also have the access to the internet and data center and so on and so forth. So nowadays, the trend is different. So it's to decentralize also this access to the services. So for instance, if you think about the over-the-top provider like Netflix or even Google. So we see that the service generator is more and more distributed closer to the user, so closer to the element that you have here in the, let me use the pointer. So closer to actually the business edge or the consumer of these services. So we see a trend where the data center, the content provider are moving into the metro, more closer to the consumer. So it's coming from the fact, this is coming from a fact, this is a de facto happening already. And so why not distributing also the peering point? Because if you keep them centralized, the traffic is growing dramatically, exponentially. The number of devices remain the same. And so because of that, the devices has to become larger and larger. And so our new architecture is based on few options to basically decentralize and distribute also the peering. And this will basically increase the number of devices, but not so dramatically as the traffic. And the traffic is basically increased linearly instead of exponentially. And of course, this is coming again with some challenges with keeping the network healthy, planning the network in an effective way, making sure that the right configuration is sent to the right devices, making sure that the inventory is still consistent with what you have in your management application. And also, it is coming from the fact that the optimization requires some automation for sure, because you cannot, what in the past you were optimizing, let's say 100 of peering point in a large service provider network. Now you probably need to optimize 1,000 of devices, so you cannot do it manually. You need to have automation in order to cope with that, because I don't think our customer will think to hire 10 times the people they have today for doing this job. So I think the workforce will remain the same or even decline. So we need to have automation for that in order to cope with this problem. And actually, we are working with the Cisco network controller, the IP domain, to help with this transition as well. So we are making group of devices that can be considered as a single entity that we can, like a cookie cutter type of template, we can send the configuration to these devices. We can re-optimize the configuration in an automatic way. So our Cisco IP controller is fundamental in this transition. So I'll stop for a second if you have any question. I don't know if there are any question that is coming online, but maybe Nicola, you would like to, any question coming online, or is like in the room addressed? Okay, any common question maybe we can repeat in the room? No? Okay, one question here.
At the beginning, you mentioned the open telemetry. Where is it used? Between appliance and controllers, or API we can use to extract data and send together with, let me say, other data?
Yeah. So the question, I think I'll try to repeat if I understand it well. So how can we consume the telemetry from the network? So first, we have a tool that is called the Crossword Data Gateway, or CDG, that is our distributed collector that is able to collect huge amount of telemetry data from the network itself. So how do we leverage those data? So those data are the basic for the insights that we have for our automation. So we have two options. First option is we send this data as is to other consumer inside the organization. So we have, for instance, if you look about the usual over-the-top provider like Google, Amazon, so they want this data in a raw format. So they don't want us to get insights from that data unless we use that insight. So they want the raw data for them to consume, and we can do that. So we can give all the data by giving them access to that. And the second option would be, okay, we can leverage those data, elaborate, normalize, and create an actionable element. So an example could be, we can collect all of the traffic pattern in the network by means of telemetry. And then when we see that there is that we exceed a given threshold in a given link or in a given portion of the network, then we can automatically, using the crosswalk workflow manager, to close the loop and resolve this congestion by re-optimizing the network. And this is an example of local congestion mitigation that is one of the key points that we have in our optimization engine. Did I answer your question? Okay, so basically we went through a little bit on the architecture. We went a little bit on the different use case where automation is a key driver or key element in order to make sure that this transitional architecture or the transition to new architecture is successful. And now we can go a little bit deeper in the portfolio. I want to spend a few words both on hierarchical controller, HCO, and the CNC. And then I want to leave some time to Paola that will describe what we are doing in the assurance with automated assurance and also with Accidian. So few words on the hierarchical controller. So it's an acquisition. So we acquired 3 years ago Sedona. It was a very successful product and a good investment for us in order to make sure that our network we are not able to manage just a single domain, but that our management and our automation is multi-domain. What I mean with multi-domain? Multi-domain could be, I have a domain, maybe because of the same technology, maybe it's in the IP, but this domain is a local domain, it's a region. And for scale reason, I have another domain, or because maybe I want to keep it distributed, then I need to have a different controller or another controller for scale purpose. And then where I do see the end-to-end visualization, where I see the end-to-end is on the hierarchical controller that basically normalize and collect the data from the two controllers and visualize in a single pane of glass. So this is for geographic separation. We may have a different vendor. So we may have one network implemented by Cisco, one network implemented by another vendor. In that case, we may have the need of use a different controller. And then in that case, even though our IP network controller is multi-vendor, and so we can cope with multi-vendor directly in the IP domain, but in case there is an existing controller, then the HCO can do the bridge to the different domain. Or it can be a different technological domain, like in the routed optical networking. So we have an IP domain managed by the IP domain controller that is CNC, and maybe we have the optical controller that is managing the optical domain. So in this case, HCO is fundamental in doing the visualization end-to-end, but it's not just visualization. So HCO is also a tool that is able to take and close the loop already with some of the use cases. Optical is one of the examples, and I'll go a little bit in the, before going into the slide, I just want to mention what is the closed loop automation that we do in optical with HCO. So the network element are becoming more and more simple. And so there are features or function like automatic power control that are not performed in software like in the past. If you talk about the RON architecture, now we not only have the transponder or the optical pluggable that you plug directly in the routers, but we can also have amplifiers. Of course, there is no automatic closed loop that is able to cope with automatic power control when you add a new channel, when you insert a new site, for instance. So all of this function is performed by the HCO. So the HCO, by installing this network and adding services, is able to modify the automatic is able to modify the working point of the amplifier that is actually working as pluggable inside the routers also in this case, so that is able to close the loop by collecting the data, the performance data of the optical, and then adjust the set point of the amplifier so that the power level are not exceeding the receiving power on the other side. So that's an example on the optical domain of closed loop automation that HCO is able to do. But what is most important from an hierarchical controller that is bringing together more domains is the multi-vendor capability. In fact, the hierarchical controller is built on the concept of multi-vendor natively. So it's built on a layer of application and is built very similar to HCO, very similar to NSO, is built around the concept of adapters. So if we have an optical domain from Cisco, we have a Cisco optical adapter that is talking to the Cisco optical network controller. But if we are having Siena, we can remove from the application or use a different adapter that is, for instance, the Siena adapter, but keep the same level of capability at the application layer of the HCO. And this is basically what this slide is talking about. So the HCO is pre-built with multi-vendor support in mind. Of course, with Cisco for us is more easy because we can pre-test and we can validate the solution in-house before giving to your customer. But we also have adapter for other vendor, and we are able basically to provide the same level of capability. What we are looking in this case, since the variation of vendors, the variation of version with the different vendor may be big, we cannot pre-test in-house all of this stuff. So in this case, an help that the partner can help us doing that is basically help us certifying the different adapter for the different vendors. So in case you have this kind of engagement, don't stop yourself and say, oh, I'm not selling this because Nokia for version, I don't know, 23 or 24.x in the NRCT is not supported yet. So we can reuse the adapter and test and verify with the new version with your help in deploying the network. So that's the key ask that may have to these audiences. Don't stop selling if the vendor is not supported out of the box, but let's ask and partner together in making sure that we can verify and test and build the solution for our customers. Yeah, so I want to skip very fast on this unless you have any question. So on the routed optical networking, there are other solutions because our solution, again, is leveraging on IP domain controller and optical domain controller HC on top. We may have other vendors like Siena that are taking a different approach that is, for instance, reusing or extending the optical controller to also manage the optical termination on the routers, so not relying on an IP controller. So we think that this seems to be a simpler idea. This is also what we had many years ago when we started with IP over WDM. So we had our EMS system overloaded using from the optical domain, managing also the optical interface on the router. So overloading basically the capability. It seems to be easy in principle, but it may come with additional challenge. Of course, this is not multi-vendor or multi-domain. So if you have different vendor in the network, you cannot extend each single EMS or controller to talk to the same router. So that is a complication. So you basically lose the end-to-end visibility. That's the first point that is not working. Another point is that you have to share the DCN of the optical and the IP that traditionally are separate DCN in the customer environment. So this could be a problem for your customer. And this is a point where when we go to competition and we say, okay, there is this solution that is more simple, this is a point that we say, okay, this is probably not the best idea. And another point is the contention on the router. So you may have different controllers, many controllers that are talking to the same interface together with the IP controller. So there may be contention on the same physical object, and configuring the same object from different elements is not always the good idea. So long story short, I don't want to get into the details, but if you encounter this problem when selling RON with the competitor, we have some good answer why we went to this architecture. And by the way, the architecture that we are building is also supported by the Telecom Infra project, so the consortium of different vendors like Telefonica, Telecom Italia. So the reason they went to that direction is because they endorse us in this choice. And by the way, is also compatible with what IETF is thinking. And so there is no standard for the architecture, but the fact that the blueprint or the suggested architecture is this one is probably another good point. So network controller. So I talk a little bit in these few slides about the hierarchical controller, how we are using it in a very specific use case like the RON. Now I'm talking about the network controller. If you have any question, please, again, ask. I will go a little bit faster because I want to give some time for the assurance. That is an important portion. But basically, CNC this is the architecture on which CNC is working on. So CNC started as a service manager. So the idea that we had originally was, okay, we have a very successful product for provisioning services that is NSO. But NSO is not doing visualization of services, is not integrated with assurance, does not have the possibility to do any, let's say, complex. I mean, it has capability to do some complex activity, but requires a lot of customization. So why not building on top of NSO and give this ecosystem a UI, some predefined use cases, and some also element management capability, like inventory, fault management, and performance management. So this is what we are doing with CNC. So you see on the top, you have the service and transport provisioning. We have the visualization. That is the most important portion that NSO alone does not have. So we have a topology view where we can visualize the devices. We can visualize the services. We can overlay services on a topology. We can show slices one by one and how they are interact each other and what services a single slide is attached to. So this is very important. And then you can see at the bottom, we have other element like element management function, very important. So we are now adding the capability to a controller that traditionally does not have it, but we understand our customer that rely on a controller. They definitely need an inventory tool. They need a tool that is able to visualize the devices and the inventory, where the pluggable are inserted in a given device. So traditionally, the customer is having a controller and then an EMS. We are building all this block together in a single pre-tested and coordinated ecosystem of product that is talking together each other by means of the same model on the same communication bus and so on and so forth. The most important portion is the optimization. That is the green portion you have here, the optimization engine, and then of course closed loop automation. So we are integrating this tool with the workflow engine so to build more and more use cases on the automation. Service assurance is definitely a very important portion, and we'll spend a little bit more later on. Network service orchestrator. So I don't think I need to present this tool to you, right? Since you are very familiar with it, very successful because we have more than almost 200 type of adapter depending on vendor, version, and so on and so forth. And it's an ecosystem that is growing, is customizable. So again, I don't need to spend more words on that unless you have any question. And by the way, if a customer has already deployed NSO, we can reuse the same installation in CNC. So if you have a customer that is already having NSO, you can say, okay, by the way, if you want the visualization, we can plug into your network the CNC and reuse the same NSO installation that you have in the network. So this is another very important portion. Crossword Workflow Manager. This is the last slide I would like to talk to you about, and then I'll give you the word to Paula. This is the new offering that we are building on. It will FCS in a few weeks. It's basically an engine similar to Ansible, but more powerful, on which we can customize by programming it what it's doing with conditional scenarios and leveraging on the data that we have on and collecting in Crosswork by means of the CDG. So it's taking insight and action from that, and it can take decision and can build a workflow. So it comes with predefined use cases, integrated already, pre-tested. but it's definitely a tool that you can customize and build your own. So this is very, very important. One of the use cases that we are building starting from scratch and pre-tested is the software download. So it's something that is coming with verifying the precondition on the devices, taking some action depending on the type of devices that you need to download the software, make the activation, and then do the post-check test, and then complete the operation. So this is, you see, it's a workflow, it's a long workflow, and it can be programmed. And now I think, well, you can build everything together and you see how we can stitch in a very nice ecosystem, but I want to give some time to Paola to talk about the automation assurance.
Thank you. Okay.
Thank you, Paola.
Thank you, Domenico. So this is more an update on the progress that we have done on assurance. As you see, the controller is like intent-based. So we start from the definition of the intent and we are deploying the intent. So the database is not anymore the network, is the intent that is actually provided by and tracked by the controller. We are following the same approach also with assurance. So the point that we have in the past was, let's actually discover everything, let's actually collect everything, and some manager was trying actually to make sense of it. The quickest way actually to understand if my service is actually degrading is not by modeling all the network, but is simply by probing the network. And the following presentation, I believe, will be on Accidian. And this is one of the reasons why we recently acquired Accidian, because Accidian gives us like the ability to actually monitor the service end-to-end. Over the top, remember that the controller, the cross-network controller, is multi-vendor. So we need to actually have a way to actually monitor the service independently of the probing capability that the different endpoint has. Of course, if we have a Cisco infrastructure, a full Cisco infrastructure, we can leverage on embedded probing, and we can leverage also on additional instrumentation that has been added into the XR. The second point, so at the top you see that we actually have positioning Accidian Skylight Analytics, because that is actually help the operator in understanding if a service is degrading. The other aspect is like the way that we added assurance functionality into the stack is not actually to add overlap functionality, but to add functionality that fit the role and know-how of the operator that is using that specific tool. So the first level, most probably it's like a high-level operator. It does not know all the technology that is underneath. So it needs actually simply to understand my service associated with the customer is degraded, yes or no. So that type of operator does not need to actually have a deep view or a topology view of the network. We need actually to have a more dashboard view that help in understanding if the SLA are met or not. And that is like where Accidian again can help, and you will have a presentation later on. But once I identify that there is a degradation of a service, and this service, for example, is running across an IP infrastructure over an optical infrastructure, at that point I will need to understand if my problem is like on the IP domain or in the optical domain. And that is where the hierarchical controller can help, because it actually provides a multi-layer view. The last point is like, well, let's suppose that my problem is then into the IP controller. So in that case, we are adding specific functionality that help operator in troubleshoot the services that is running and visible through the IP controller. Let's see. So I'm going directly on the functionality that have been implemented in the cross-network controller, because again, Accidian is going actually to be covered later on by Tom Footy. So the way that we actually proceed into the controller is again a top-down approach. So we start actually adding, the controller actually have the visibility of the service. So we start actually adding the service health. Service health represents the innovation that we added in the controller. It's like aligned to a ITF concept that, or not the RAF, and is an RFC right now, called service assurance for intent-based networking architecture. And I will go later on this concept. And then we are using probing that can be embedded or external to actually understand if the service is healthy or not. The other aspect is like when the service is healthy, well, let's actually move a level down, right? If I have a visibility of my transport path, I can actually monitor the transport path using SRPM. SRPM is an instrumentation that has been added on the XR, is a TWAMP or simple TWAMP stamp based or TWAMP light standard that is actually leveraged at the SR level. And then, if I actually have at that point also the visibility of the infrastructure, I want actually to add additional information of the on the infrastructure. So I'm not starting anymore from an interface and understand if a service is impacted, but I'm starting from the service and drilling down to the specific interface that is associated to that service. And that is the reason why we actually are adding element management functionality that we took from EPNM and we are bringing in as part of the infrastructure health. Recently, last week, we actually have also a demo at ENTC, at the MPLS World Congress, where we show also how we can actually provision and monitor slice across actually multi-vendor environment using the same structure. Because once we have the different building block, we can also provision and monitor a slice. So step by step, like starting from the bottom, infrastructure health. What I'm going actually to have, as I said, that we are bringing in some of the functionality that we have in EPNM. So we are bringing in inventory because when I actually have a problem on the service, on a specific interface, I want actually to relate to that interface, to a port, to a line card, to a slot, and to the device where that interface is sitting. So I'm not actually looking at the interface and trying to understand if the service is impacted, but I'm starting from the service and going down. So in this way, the operator is not flooded by information, but is driven through the troubleshooting to a specific step, and we give more and more information as is drilled down to a specific entity. The other aspect that we have added is alarm. So when I drill down on a specific device, I can see all the alarm. We also actually provide a complete alarm and event view across the network. The last point that was like important, and we are adding that in 7.0. So one of the concept of service health was more around, okay, I actually enable the monitoring of different components of the service, but I'm going to track the metric only when there is degradation. Anyway, most of the operators, they were saying, well, for some key metric, we want actually to continuous monitor that. So we added those key metric as part of the infrastructure monitoring. So we can actually track historical trending for some metric on the pluggable, like the ZR pluggable, or on the interface, or on device, like CPU, temperature, and so on. And of course, we can generate a threshold crossing alert. The second step is like, okay, I have the visibility of my infrastructure. I'm actually, what I was saying is like at the traffic engineer level or at the SR, because SR level or RSVPT level, I leverage on SRPM. SRPM, again, is a TWAMP-based tool. So how I use this TWAMP-based tool? I use the TWAMP-based tool to do two types of use case. One is like to monitor link, core link. So we are enabling TWAMP, and so it gives us the jitter and latency across, the different link. Why we are monitoring link? Because most of the time, a link degradation is causing a service degradation. So you will be able actually to see your service overlay on the topology and see which are actually the link that are going actually to be degraded. The other part is like we are using SRPM to monitor a policy. So for each services that is degrading, we can actually see which are the policies that are associated to that specific service and see which is like the specific policy that is actually degrading. Now, how service health actually bring that together? So service health, I was saying, is based on an ITF RFC 9417. The concept of service health is, again, I believe that you are familiar, right, with NSO and the concept of function pack, yes or no? Yeah, you are. So service health, think about service health as the same concept of configuration applied to monitor. In the configuration, when I define a function pack, I define how to configure a service. For each service configuration, I have a definition of how to monitor the service that is based on the type of service and the type of configuration that is deployed through NSO. So that definition of how to monitor a service, it's called a heuristic package. So by the definition of the heuristic package, based on the configuration of the service, the system will generate an assurance graph like that. So it's based on, the definition of the service itself. You see different branch. Of course, those branches are present or not present, dependently if there is a specific configuration. So for example, this is a layer 2 VPN with a Y7031 probe. Of course, if I didn't have provision a Y7031 probe, simply the branch is not there. And this is automatic. So every time I change a service, for example, I add a new endpoint, you will see a new branch appearing as part of that specific service. And then all the components that are part of this branch are called subservice, and they are monitored independently. So at the end, when one of those components is degrading, and is degrading based on the definition that we are having in the subservice itself, is going actually to be exposed. So with this view, you have a single view of how your service is behaving, if it's degrading or not, and which is actually the reason of that degradation. The other part is like every time there is a degradation, we are storing information. So you can go back in time and see if the problem that I see today, I see also in the past. So it's more an help for the operator to troubleshoot that deep a service. Another part that we have done, of course, we actually have extending service health. More, we add, more we are extending service health. So originally we have extended with monitoring the SRPM, integrating with the SRPM, and recently we actually have done also the integration with Accidian. So the way that we are integrating Accidian is like we are using the result of the Accidian probe actually to combine the view with the rest of the information that we have for traffic engineer and the infrastructure through service health. So there are two aspects of this integration. I'm not going into the detail. You will see, I believe, more during the demo, maybe. So one of the points is like we are using NSO and the definition of the service to actually describe how I want to monitor that service. So we call it zero-touch assurance. So we are provisioning using NSO. We are doing that configuration that is required to monitor the service, like I provision sensor path, I provision a probe if I need actually to do. In the case of Accidian, we are saying which is like the type of how many sessions I want, and which is like kind of the topology that I want, full mesh, hub and spoke, or point-to-point. So the system will actually require to the Accidian between quote orchestrator, this gateway road runner, I want a session from here to there. So cross-flow network controller does not know where the different probe of Accidian or sensor of Accidian are deployed, which is the type of sensor that is deployed. It's just asking, okay, I want a session from here to there. If the probe is there, the Accidian orchestrator will answer, here your session. If the probe is not there, we'll simply say there is no session that I can actually initiate. The other aspect is like when we ask the session, we provide also some information, what Accidian call metadata. And those same metadata are going actually to be used to enrich data when they are actually sending that through GNMI, through the cross-flow network controller. So in this way, we are combining the view that we have from Accidian from the view that we actually have from the infrastructure. One of the points I was saying at the beginning, we are not actually going to replicate assurance function across all the stack, but we are adding additional information step by step. So in the case of the cross-network controller, we are not actually consuming all the data that the Accidian sensor can provide. We are not going to do specific analytics or trending analysis of all the data that the sensor are doing. This type of functionality are going actually to be provided by Skylight Analytics. So if we want to actually have trending analysis and so on, I can use Skylight Analytics. If the goal is like, I want actually to help to enhance the visibility of my network into the controller, then where I use like the cross-network controller and the integration with the different probe. This functionality is limited available with sensor agent in 6.0 and is going to be generally available leveraging an SFP in 7.0. And I believe that that's it. So which are the benefits? Of course, we improve the overall user experience because we can actually track exactly which is the user experience while it's traversing a transport network across the different layers that we can see. And we can also help the operator in the overall troubleshooting because by modeling how to monitor a service, we can automate some of the troubleshooting steps. So expedite troubleshooting, we can actually provide true service impact. Again, we monitor the service and we monitor the components that are actually part of that service. We are not actually to monitor everything, right? So that gives actually true service impact also through the leverage of the result of probing activity, of probing information. And action by codifying the know-how that we have in troubleshooting, we can actually automate some of the troubleshooting steps. So I've been very, very quick because I didn't have a lot of time. The point is like with the cross-network controller, we come up with two different types of service out of the box that we support both from configuration monitoring perspective. Those are layer 2 and layer 3 VPN. We are going to extend actually to PLE when we are going to support also PLE. We already extended to service to slicing. So this is like a bit of summary of those functionality.